Okay, let's take this language again. L1 equals to A comma AB. So the DFA for it, I'm making it one DFA. Okay, when you make DFA, try to make it a minimal DFA in the first flow. So this is the minimal DFA for minimal DFA for L1, right? If you look at the state sequences for different, I will be having different strings. Okay, let's have a different strings and look at what the state sequences for those strings are. So we have W1 equals to epsilon. When W1 is equal to epsilon, the input tape is empty. This is the input tape is empty, and before you see any symbol, you are at an initial state. So this is what the state sequence for W1 is, Q0, and Q0 belongs to non-final state. So epsilon is not accepted by M1. Not accepted by M1. Let's say this minimal DFA for L1 is M1. Okay. Similarly, if you take W2, as A, then what is the input head? It is A. So when you are initially you are at Q0 without seeing any symbol. Then the tape head is A, so you move from Q0 to Q1, and that's the end of the string. So you end up in Q1, and Q1 belongs to the final state. So W2 is accepted by M1. It is accepted by M1. Similarly, if you look at W3 and as AB, then the input tape is like this, A and B. Initially you are at Q0. When you see A, it goes from Q0 to Q1. From Q1, when you see B, at Q1, when you see B, then it goes to Q2. Okay. So Q2 belongs to F. So W3 is accepted by M1. So we were talking about state sequence, right? So state sequence of W1 is Q0, W2 is Q0, Q1, and W3 is Q0, Q1, Q2. If I take any other W, let's say W4 is A, B, C. So W4 is A, B, C. A, B, C. Initially you are at Q0. On Q0 on seeing A will go to Q1. Q1 on seeing A will go to a dead state, right? Look at here. Q0 on seeing A. 1 minute. Q0 on seeing A goes to Q1, and Q1 on seeing A goes to QD, which is a dead state. And then whatever will come, it will stay at QD, right? So it is Q0, Q1, and then it will repeat. Q1 will repeat. Okay. And so we have taken all these examples where W1 is not a part of the language, W2 is a part, W3 is a part, W4 is not part of the language. Okay. Now what we will be doing is this. Let me make a little change in the DFA. Let me do one thing. If I add a new transition to this DFA only, if I add a new transition, let's see what changes, how the language of the DFA changes with this new transition. what I am going to do is I am going to have a backward edge from Q0 to Q1 also. Okay, so recreate this DFA with a backward edge from Q0 to Q1. This is M2. Now for this DFA, if I take W to be A, A, B, A, A, B, initially you are at Q0. On seeing A, from Q0 you will go to Q1. Q1 on seeing A will go to Q0 again. Will go to Q0, and Q0 on seeing B will go to a dead state QD. Okay, so because QD is not a final state, so AAB is not accepted by DFA, not accepted by M2. If I take W to be A, 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 B. If I take W to be A, B, then what is the state sequence for this? It will be A, B. So initially you are at Q0. Q0 on seeing A goes to Q1. Then the tape head is at this A. Q1 will go to Q0. Then the tape head is at here. Tape head is here. Then it will go to Q1 again. And then from Q1 it goes to, and then at Q1 when it sees B, it goes to Q2. Q2 belongs to the final state, so W is accepted by M2. Let me make it W2. Okay, W2 is accepted by M2. Okay, very good, very good. Now, if you see, Q2 is final. Q2 is final state. Okay, Q0 is initial state. So, if you look at the state sequence from initial to final, what is the state sequence from initial to final? So, Q0 is initial, and Q2 is final. And in between you have Q1, Q0, Q1. Q1, Q0, Q1, Q0, Q1. This is the state sequence. This is the state sequence for W2. What is W2? A, B, right? That was W2. A, B, yes. So this is the state sequence for W2. Okay. Now, if you look, you have a repetition of state. In a state sequence, you are going from initial to final. You are going from, there is a path in the state sequence, there is a path from initial to final. There is a path from initial to final. And within that path, you have repetition of Q0. Repetition of Q0. Right? You may say there is also repetition of Q1. Repetition of Q1. So you have moved from Q0 to Q0. In a way, means you have seen some, in a way you have seen some string. Okay, you have seen some string, and that has led you to come back at Q0. So initially you were at Q0, then you saw some string and you come back to Q0, right? You were at Q0, you saw some string and you get back to Q0, and that string happens to be here what? AA, right? See, you saw A, you go to Q1, then you saw A again, you go to Q0. So you saw AA and you get back to Q0. So when you are at, okay, very good, very good. If I ask you, what if you saw AA, AA? What if you saw AA? Where you would end up? So if, let's say, if the string to be traversed, if the next immediate strings to be traversed is AA, okay, if the tape head in the next immediate string to be traversed with the tape head is AA. So initially you were at Q0, then you will you will go to Q1. From Q1 when you see A, you go to Q0. From Q0 when you see A, you go to Q1. From Q1 when you see A, you go to Q0. So again you will end up at Q0. So any number of AA comes, if you are at Q0, then any number of AA comes, then you will stay at Q0. Is it not the case? That is how the move is. You are at Q0, you see A, you go to Q1, you see A, you come back to Q0. So any number of AA comes, AA star comes, you will be back to Q0, right? So this repetition of states in the state sequence confirms that there was a cycle between the states, right or no? Yes, I have explained this before also. Now tell me, this was a state sequence for AAAB. So, and AAAB was accepted. This was a state sequence for AAAB, and AAAB was accepted by the DFA because it ended up at Q2. There was AA here, and it comes back to Q0, and then you saw A and you get to Q1, and then from Q1 you saw B and you get to Q2. Now we can see that in reality, when there is a repetition of state, it means that we can derive other strings from this information only. From this information, that there was an initial state, you got a final state in the state sequence. Within the state sequence, from initial to final, there was a repetition. From this information only, you can derive many other strings that is also accepted by the machine. How? Very simple. It was Q0 on seeing A goes to Q0, and then when you see A it goes to Q1, and then you see B it goes to Q2. It means that from Q0 if you see A it will go to Q1, from Q1 if you see B it will go to Q2. Here also from Q0 if you see A it will go to Q1, from Q1 if you see B it will go to Q2. So Q2 is the final state. So AAAB so this means that AAAB belongs to the language. let's not talk in terms of language. Maybe it's not wrong to say in terms of language. I am talking about, it means AAAB is accepted by the DFA. Also, it means that AA, in place of AA, we used AAAA, and then AB also belongs to the language. And similarly, we can say from here that AA star AB also belongs to the language. So this is the inference that you get when you see the repetition of states in the state sequence. Okay, you can derive many other strings that is also the part of the language, or many other strings that will also be accepted by this DFA, which is a representation of that language, right? So this is one of the point. Okay, one thing. Another thing, when I say many other strings, I mean infinite strings. AA star is less infinite. So repetition of strings, so repetition of states in a state sequence. So repetition of states in the state sequence in the state sequence. Say you have a state sequence qi plus 1, qi plus 2, so on, qj plus 1, qj plus 2, so on, qj, so on, qk. So you have a repetition of states. Qj, right? This is the repetition of states in the state sequence. Now this repetition means that from Qj you have seen some string, and that has this means that whatever string that we have seen, it means, let's say this was W. So it means that Qj on seeing W will get back to Qj, right? And it means that Qj on seeing W star will get back to Qj. Okay, for anybody who is not aware of this symbol star, then if you are not aware of this symbol star, I actually thought that this was I'm sorry to not introduce it, sorry. So let me introduce it right now. In the video on alphabets, yes, symbols and alphabets. Let me take a new page. In the video on symbols and alphabets, we talked about summation star, right? Sigma star. That alphabet is sigma. Let's say if it is A comma B, then what is sigma star? Sigma star is sigma. Sigma star is sigma to the power n, where n can be greater than or equal to 0. So when you see this star now, it means that just repeat it for n times, or repeat it for as many times. Means it includes every possibilities, including no possibility, right? So this is what it is. So in this case, if a string is given, for example, let's say a string AA is given, and I do AA star, it means what? It means epsilon, it means AA, it means AA, it means AA, and so on. Means that AA to the power 0 union AA to the power 1, which is this, union AA to the power 2, which is this, union AA to the power 3, which is this. So this is what this symbol is called clean closure. Okay, there is a thing called as regular expression that I will introduce very soon. I'll introduce this very soon, and we will learn about regular expression parallelly while we will be constructing DFAs for infinite languages. Regular expression will be also dealt with parallelly. Okay. So coming back to here. So if you have such a thing that if you have a repetition of states in the state sequence, it means this. It means this. So when you have repetition of the states, it means this. Very good. And it also means, okay, so now QK can be final and it may be non-final based on a given string. If a string belongs to the language, it may end up in the final state. If it does not belong to the language, it may end up in the non-final state. If QK is final, if QK belongs to the final state, we will take these two cases one by one. If QK belongs to final state, if QK belongs to the final state, or QK belongs to, if QK belongs to non-final state. We will see these both cases that just now. Let's say this string was WT. This string was WT. This WT is accepted by DFA. WT is accepted by DFA, right? Because QK is final. WT is what? WT is bunch of symbols, then it gets W and then bunch of symbols. Means whatever specific WT it is accepted by DFA. Means that it gives rise to many other strings which is accepted by DFA. It is accepted by DFA. Okay. So this is what repetition of states. This is what you infer from the repetition of state in the state sequence. When QK belongs to the final state, and you come to know that, and you derive that WT is accepted by DFA, you not only get WT, get the result for WT, but you also at the same time understand that there are many other, which is in fact, because this is a star, infinite many strings that is going to be accepted by DFA. Similarly, if the QK does not belong to the non-final, if QK belongs to non-final, then WT is not accepted by DFA. WT is not accepted by DFA. WT is something, some symbols, then you see W as mentioned here. Right? This is what WT is. It means it is not accepted by DFA. And then it means what? It means that you not only conclude that WT is not accepted by DFA, you get many other infinite strings which is not going to be accepted by DFA if they follow this pattern, right? Not accepted by DFA. Okay. Now in the upcoming videos we will be looking at infinite languages, and we will try to construct DFAs for the infinite languages, right? If DFA is possible for that infinite languages. So this is it. In case of finite language, DFAs are possible. All finite languages are regular, but not all infinite languages are regular. Okay, not all infinite languages are regular, and we will see how to prove whether a language is regular or not in later videos. Remember the observations about the finite, about the DFAs for finite languages. What was the observation? The observation was this, that there cannot be any cycle, or there cannot be any loop from the states that has a path to the final state. Just in the last video we saw that if there is a state and you have from that state you have a path to go to the final state, then this state in nowhere will be a part of any cycle or will be a part of any self loop or loop, right? In case of DFS for finite languages, right? Yes, because if it was a part of, then it will give rise to it will give rise to a DFA for some other language, and that language will happen to be some infinite language. Okay, so this is the point you have to remember. You have to understand. So this is the point that I am trying to make. DFAs for infinite language. In DFAs for infinite languages, between initial and final state, in DFAs for infinite language between initial and final state, or the states. So in DFAs for infinite language between initial and final state, or the states from which you can reach to the final state, there has to be at least one loop or self loop, or you can say cycle, loop or self loop, something like that. Just like in the DFAs for infinite languages, there cannot be any loop or self loop, otherwise this is not a DFA of any finite language. Similarly, if it's an infinite language, of course it depends on the language how we will define the state transitions. But if it is an infinite language, then between initial and final states, all the states from which you can reach to the final state, there has to be at least one loop or cycle or self loop or something like that. Why? Because this loop or this cycle is what produces multiple strings. This is because this loop or cycle is what produces the repetition of states. Because of this loop or because of this self loop, because of the loop between the states, because of the forward and backward movement between the states, is what generates repetition of states in the state sequence, right? In the state sequence. Oh, so repetition. Okay. Yeah, that's it. And in the next video, we will look at the DFAs for infinite.